All right, today we are cracking open the playbook for anyone who's serious about building with AI. We're diving into Chip Huen's fantastic book, AI Engineering. We're going to lay out the blueprint for how you build real solid applications that actually work in the real world, using today's most powerful AI models. And you don't have to take my word for it. Right off the bat, you can see the kind of weight this book carries in the industry. This is not some academic exercise. It's a super practical guide for the people who are actually on the front lines building this stuff, covering the whole shebang from the first sketch to deploying at scale. And this right here, this is the big idea that changes everything. You know, AI used to be this mysterious thing locked away in research labs. Not anymore. Now, it's more like a set of super-powered Lego bricks that anyone, and I mean anyone, with a good idea can start building with. Okay, but this is the million-dollar question, isn't it? It's one thing to whip up a cool demo that works, most of the time. But it's a completely different ballgame to build a reliable, production-ready app that people can actually count on. And that huge gap, well, that's what we're going to explore today. So before we can build anything, we have to know what we're working with, right? What are the actual materials in our toolbox? In this new age of AI, let's take a look. I'm sure you've heard the term LLM thrown around everywhere. But things are already moving way beyond that. See, LLMs are masters of text, and that's awesome. But foundation models, that's the next step. They're multimodal, which is just a fancy way of saying they can understand and work with images, video, audio, and more, not just words on a page. And that is the most important part. The word foundation is in there for a reason. These models aren't just one-trick ponies. They are these massive, pre-trained bases that you can then take, tweak, and build on top of to create a ton of different specialized apps. Okay, so we've got these incredibly powerful foundations. The next logical question is, what are people actually making with them? Let's see what's popular out there right now. Now, this is really interesting. When you look at over 200 open source AI projects, what jumps out? Coding assistants are huge. They're everywhere. But then you see these smaller slices for things like writing and education. And you might think, I thought those were big. And they are. It's just that those tend to get built as big company products, not so much as open source projects. And just to give you a taste of what these coding tools can do, we are not just talking about auto-completing a line of code. No way. We're talking about taking a screenshot, a flat picture of a website, and having the AI turn it into a working web page. That is a wild leap in what's possible. With all this incredible power, you'd think shipping a product would be a walk in the park. You get a great result one time in the demo, so you're basically ready to launch it to millions of users, right? And this is where the hype train slams on the brakes and meets reality. That journey from a cool demo to a product people can rely on, it is full of traps and hidden problems. This number tells the whole story. A team at LinkedIn said getting their AI feature to about 80% quality, that took them just 1 month. Pretty good. But that last 20%, getting from 80% to a truly reliable 95%, that took them 4 more months. That last mile is an absolute grind. And here is one of the biggest reasons why that last mile is so tough. Hallucinations. That's when the model just makes stuff up. Look, for creative writing, that can be a feature, but for anything that needs to be factual, it's a total disaster. I mean, a law firm was famously fined a ton of money because its AI-written legal brief cited court cases that were completely made up. Yikes. So how do we get around all these challenges? How do we build things that don't just make stuff up? Well, you need a plan, a disciplined, structured approach. You need a blueprint. And that is the heart of what AI engineering is all about. This is the key. AI engineering takes you from just messing around and hoping for the best to a repeatable professional process. You build your app systematically. You test and measure its performance like a hawk, and then you deploy it. And then you do it all over again. It's this discipline cycle that lets you build systems you can actually trust. So you're in that cycle. How do you actually know if you're getting better? That brings us to maybe the most critical part of the whole blueprint, evaluation. Because if you can't measure if your app is working right, you're basically just flying blind. But here's the tricky part. Checking an AI's work isn't like checking a math problem where there's one right answer. Even a simple sounding idea like faithfulness, does the AI's answer actually stick to the facts you gave it, can mean totally different things depending on which tool you use to measure it. I mean, just look at this. You've got 3 popular tools, MLflow, Ragus, and Llama Index, and they all say they measure faithfulness. But one gives you a score from 1 to 5, another gives you a 0 or a 1, and the last one just says yes or no. They are completely incompatible. You can't compare them. This ambiguity is a massive headache for builders. Okay, so let's say you've figured out a solid plan for how you're going to measure success. How do you actually design your app to be more reliable in the first place? One of the most important design patterns in AI today is something called RAG. The whole idea here is simple. You give the model a cheat sheet. Instead of asking it to remember something from the billions of things it learned during training, you give it the exact correct information it needs right when it needs it. And here's how it works in 4 easy steps. 1. A user asks a question. 2. Your system instantly goes and finds relevant documents, say from your company's internal wiki. 3. It bundles those documents together with the original question. And 4. It hands that whole package to the model and says, hey, answer this question using only the information I just gave you. This one technique drastically cuts down on those pesky hallucinations. So let's zoom out and pull all these pieces together. What does this new discipline of AI engineering really mean for the future of how we build things with technology? This is probably the most important thing to remember. AI engineering isn't about building one thing, launching it, and then forgetting about it. The models underneath are constantly changing, getting smarter, faster, cheaper. Your job as an engineer is to build a system that can ride that bullet train of change without falling off. We've gone from an era where AI felt like magic to one where it feels like engineering. We now have the blueprints, the patterns, the principles to build amazing, reliable tools. So the only real question left is, what are you going to build with it?